Swayam Prabha. Digital India. Educated India.
Drawing and computer graphics. We are in module number 2, lecture number 17. We are learning about conic sections. In these conic sections, we have already covered how to construct an ellipse and also a parabola. In today's class, we will learn about how to construct a hyperbola. There are two methods quite popular for constructing hyperbola. One is focus directrix method, other one is rectangle method, and we are going to learn about focus directrix method. Just to recall, in focus directrix method, there is a directrix and focus is away from this directrix at certain distance, and when eccentricity is greater than 1, for example, like 2 eccentricity here, it construct a hyperbola. The basic definition of this eccentricity and focus from the directrix is, from focus, if we are going to measure any point on that curve hyperbola, that distance to the distance of that point to the directrix always be equal to the same number. For example, if eccentricity is 2, let us pick this point P, from focus to that point and from there to directrix, it makes equal ratio 2, whether this point or this or any point. Using this principle, we are going to construct a hyperbola. So, after construction of these hyperbola using focus directrix method, we will end up with this curve. Let us do that step by step, how to construct it. The first thing, draw a directrix AB and axis CC prime. First, we have to draw AB. And CC prime also we have to draw. Once done, mark focus point F on CC prime. So, somewhere F we have to mark it in such a way that C to F is already given 50 mm. With that 50 mm, locate it. Once that's done, divide CF into 5 equal parts. For hyperbola of eccentricity 2, we are going to construct. So, first we divide this C to F into 5 equal parts in such a way that eccentricity 3 by 2 or 1.5 we are going to construct. So, once it is divided into 5 equal parts, 2 parts location we are going to locate V point. So, C to V is 2 units and V to F is 3 units. In that way, we divide this entire C to F part. Once that is done, we draw a perpendicular VG is equal to VF passing through V point. So, from V point, draw a perpendicular line in such a way that V to F whatever the distance, V to G also same distance we will be having. Then join G and C in that way. Then mark few points 1, 2, 3 on VC prime. So, V point is known, C prime point is known. So, what we are going to do is divide into different number of parts. These are arbitrary points, and from those points draw vertical lines, perpendicular lines in that way. And these lines are going to intersect the extended line CG at 1 dash, 2 dash, 3 dash, 4 dash and so on points. So, look at this one. So, where it is intersecting, that is 1 1 dash, 2 2 dash, 3 3 dash, 4 4 dash. Once it is done, measure from 1 to 1 dash. Whatever the distance, transfer the distance from the focus point all the way to cut this 1 1 dash line. So, first measure 1 1 dash and from focal point use a distance of 1 1 dash, make an arc. Similarly, from focal point make an arc of 2 2 dash. Similarly, from focus point make an arc of 3 3 dash and so on. Once it is done, we will be in a position to join V all the way passing through this point, so that a hyperbola we will be in a position to construct. Let us do that on our sheet step by step. First, we have to draw AB line and then CC dash. So, let us construct AB dash, a directrix. Mark A somewhere B. At middle line, horizontal perpendicular thing, we can construct CC prime. So, let us call this CC prime. This point is C, somewhere C prime. So, two perpendicular lines, construction lines we have done. Now, mark F on CC prime such that CF is equal to 50 mm. So, on the sheet locate 50 mm somewhere here. So, mark this one as focus point. Once is done, divide that into 5 equal parts. So, 5 equal parts, first, second, third, fourth, fifth. So, in that at second point locate V, because 1.5 ratio or 3/2 ratio we are going to construct. From focus point all the way to the point on the curve V is 3 units and from V to directrix 2 units. So, 3/2 units we are going to construct it. Once V is done, we can construct a perpendicular line passing through So, we will be in a position to construct this perpendicular line. Now, transfer VF is equal to VG. This is the one, transfer this line. Now, join V and G. A construction line again from C all the way to G. Extend it. On both sides one can construct it. Once it is done, we have to locate few points 1, 2, 3 on VC prime. So, let us mark few points somewhere here 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 10, 11, 12, 13 and 14. These are the points what we are going to locate it in such a way that our roller scale, through that we will be in a position to mark draw few more lines. Make sure that this always be horizontal. So, we will be in a position to draw many more lines. Once that is done, we have to transfer this lens, the vertical lens where they are going to intersect. Pick this one. Let us mark these intersection points 1 prime, 2 prime, 3 prime, 4 prime and 5 prime, 6 prime. Anyway, 7th one is going to construct 7 prime. Now, transfer this lens 1 from focal point all the way to join, intersect that, then locate the point intersection 1. Once done, transfer this point to all the way to second point. This second point here. Then third point, let us transfer it. This is third point, from focal intersect it. Then fourth one, somewhere beginning here all the way, locate fourth one. Then fifth one. So, it is going to intersect somewhere there. Similarly, from this point, six, intersect that. This is the way we construct all these points. Now, join these points. Hyperbola is very fastly changing its curvature and also the slope from here. So, having many more points, we will be going to have a very smooth curve there. So, let us join these points through a smooth curve. This is the way we construct part of that curve. Let us call hyperbola. The same lens, extending these lines all the way down, one will be in a position to construct. For example, let us pick this one. And similarly, pick this line. Transfer these lens on the vertical axis. Because of symmetry, we will be in a position to transfer this lens. Otherwise, from focal point again we have to make such kind of lens and transfer it. Similarly, extend these lines also from 1 this not anymore. Use a roller scaler, construct such kind of lens. Once it is done, we will be in a position to join in that way. This is the way we construct a hyperbola. So, till now we have looked at very interesting curves like ellipse, parabola and hyperbola. These are the curves generated from a cone and we usually call them as conic sections. And now we are going to look at special curves used in mechanical engineering. These are cycloids, spirals, involutes and helix. Let us look what are they. The first one is a cycloid. So, if we are taking a circle, for example, let us pick a circle, locate the first point something like P, which is going to touch the bottom, and if this circle is rolling on a flat horizontal base, if it is rolling on this perfectly horizontal base and this P point never slips, then the motion of this P point as circle rolls, whatever the curve tracked by that, we call it as cycloid. For example, this P point next instant of time reaches to somewhere there and this entire circle rolls. So, if we are tracking or keeping a pencil or pen on that point P, whatever that track we are going to get, that is what we call cycloid. And at mathematical level, the x coordinates and y coordinates, one will be represented in a parametric form, x is equal to a multiplied by t minus sin t, where t is the time or parametric variation. Similarly, y is equal to a multiplied by 1 minus cos t. So, whatever this x coordinate, y coordinate we are going to get from these parametric equations, that is what we call cycloids. Spirals. So, they begin somewhere at center. Archimedean spirals are quite popular in that sense. They begin, as angle increases, the radius also increases. So, as I am beginning from 0 degrees, increases to 10, 20, 30 and so on 360 degrees, gradually the radius also increases. Radius can increase, decrease based on how we are going to move this curve. If we are moving outside, radius increases. As I am going inside, the radius decreases. This kind of things are called spiral, and the parametric form for spiral is r is equal to a theta. As theta increases, r also increases for a positive definite a value, and for a negative definite a value, r decreases as theta increases. The other form of special curve is called involute. So, if we are winding a thread or rope around a cylinder, so let us take a rope of fixed length L, tie it on one side of the cylinder. Now spin the cylinder. The rope length continuously, it try to own the circle or cylinder, and the length, whatever the apparent length we are going to see, that continuously decreases. And the curve tracked by one of the end of this rope is called involutes. For example, this is the cylinder. Let us consider this is the cylinder, circle in 2 dimensions, and this is the rope which perhaps we might have tied it there. Now spin this cylinder. So the point P, or perhaps wind this rope, so that point P, it moves on a specialized path. Gradually the distance, the apparent distance what we are going to see from the rope point to that end of the cylinder decreases, and it follows a curve named involutes. The other ones are helix. So, for example, here a point which goes in a circular format, but it has axial motion also, so that it rises upward direction and so on. Typically, small size air bubbles in Coke bottles or perhaps in water beakers, when they are rising, they make this kind of spirals. So, basically it is a circle which is trying to move in the axial direction. Such kind of things are called helix. For example, springs, if we are seeing the typical pens, if you are opening that, whatever the springs you have it, they are having always constant radius, and they are continuously increasing in the axial direction. They move in that axial direction. Such kind of things what we call helix. In spirals, the radius is continuously increasing or decreasing. For helix, this radius is nearly constant, but axial direction, z axis, increases. In the next class, we will learn about how to construct these special curves like cycloids, spirals, involutes and helix. See you in the next class. Thank you.